Hi YouTube. Today I will be recording my third and final video showing implementation of the SEIR model for tracking COVID spread in a programmable calculator language. In my previous videos I implemented the SEIR model in the algebraic operating system of the TI-66 and in RPN of the HP35S. But today I'll be implementing SEIR in RPL, or Reverse Polish Lisp, the language of the HP 48, 49, and 50 graphing calculators. Because this is the third video, I'll just briefly explain how the model and the simulation work. The SEIR model stands for susceptible, exposed, infected, and recovered. The differential equations describing this system are based on susceptible being converted to exposed based on susceptible infected interactions. Conversion of exposed to infected that then can make susceptible individuals exposed. And then finally, when those who have been infected recover and no longer transmit infectious particles, they end up in the recovered category. And these equations are defined by initial SEIR parameters, then constants for the differential equations, and dt and tmax for the simulation. The method I'm using for the simulation is the semi-explicit Euler method, where I calculate changes in those different variables based on dt and the differential equations, and then iteratively add the ds through dr changes to previous values for each of the variables that I'm simulating. And with that, I'll go ahead and start my simulation. So what I'll do here is enter in SEIRSIM, which is the program in RPL. And I have this program as a text file in the description. Okay. Now I'll go ahead and evaluate that. Okay, so I evaluated SEIRSIM, and now I have a set of parameters I have to enter. For starting susceptible, 0.9999. Starting exposed, 0.0001. Starting infected, 0. Starting recovered, 0. Alpha, 0.2. Beta, 1.75. And again, alpha is 1 over the incubation period. Beta is the contact rate, and then gamma, and then gamma, as I was saying, is 1 over the mean infectious period. Gamma is 0.5 for coronavirus. It's a 2-day infectious period. And let's see here. And then rho, no social distancing in this case, dt of 0.1 days, and a tmax of 40 days. I'll go ahead, press enter, and then this will take a couple minutes to run. Unlike my previous videos, I have a printer that works with this calculator, so I'll print out the output from with and without social distancing, and we can look at a comparison in that. Alright, it's been a few minutes, and now my simulation is complete. As before with the TI-66 and the HP35S, after 40 days we have about 24% of the population susceptible, 25% exposed, 10% infected, and 40.7% around recovered. Unlike my other calculators, this one has an IR output, which makes it possible for me to print out these results to the HP82-240A infrared printer sitting behind it. So why don't I go ahead and do that? I'll open up catalog and I'll enter in the prstc command, or print stack compact form. And let's watch that printing. Okay, so I'll go ahead and tear off that piece of paper and save it for the next part of the simulation when we compare the results with and without social distancing. So that's great. I have that saved, and I'll clip it off after I record this clip. But what's urgent now is to rerun the simulation with the social distancing parameter. So enter, evaluate, and let's set that up again. So 0.9999, 99.99% of the population susceptible, 0.001 exposed, 0% none infected, none recovered, 0.2, 1.75, 0.5, and now 0.8 for row like I did in my previous videos. 0.1 days for DT, and for Tmax I'll again do 40 days, press enter and let this run. And in a couple more minutes I'll have the result again. I'll print that result and compare the old and new simulations. Okay, it's been a few more minutes and now we have the results of our simulation with the social distancing parameter being set to 0.8, so with social distancing being included. Look at this now. 74% of the population is still susceptible. 11.5% of the population is exposed. 3.6% is infected, and 10.6% is recovered. Now, like before, I'll print it out, and then we can compare the results of the old and new simulations. I'll go back right shift, cat for catalog, that should be where I left it, and we'll do PRSTC, print the stack in compact form. Rotate a little bit. I'll rotate on one axis of my tripod and zoom in, and we can see we got a result there. So I'll go ahead and cut that off the printer, and then we can compare the results of the two simulations. Alrighty, now I've printed out the results of both simulations, and we can look at them side by side and realize just how great social distancing is, as we did in the previous videos. Look at that. With no social distancing, after 40 days, 25% of the population is exposed and 10% is infected, or infected and infectious. Now, with 80% as much contact, just 20% social distancing, there's 11.5% exposed and 3.6% that are infected. Let's look at the difference. With just 80% less contact, there's at least a twofold decrease in infected and exposed. And again, this shows just how important it is to socially distance even a little bit, as we saw with our other calculators. Now, to wrap up, I want to compare some of the features of this calculator with the other two that made this simulation have the same result, but be a little bit easier to compare in our minds. This calculator, this HP49G that's just synced to the right here, I'll let it come back into view, has an ARM, a 32-bit ARM processor running at 75 megahertz. The TI-66, for comparison, I think is 200 kilohertz, and I believe the HP35S is somewhere in the megahertz range. This is a 32-bit processor in the 49G Plus. In the TI-66, there's a 4-bit processor. In the 35S, there's an 8502, a relative of the 6502, so that's 8-bit. Now let's think about speed. The 49G finished the simulation in about 2 minutes. For the optimized RPN code in the 35S, it was about 5 minutes. And for the TI-66, it was an hour. So obviously you get your result much quicker with this calculator. But more importantly, you can print via infrared using the 49G Plus, and you definitely can't do that for the 35S. For the TI-66 you can, but the printer's hard to get. In a future video, I'll hope to show a way you can get TI-66 output on your computer. But those are just some features of this calculator that make it oh so much better for doing this simulation. It's very quick, and you can easily print your results and then compare them on paper. And with that, I appreciate your attention. Please like and subscribe down below. There will be more calculator videos coming in the future. And please leave your comments if you have any more ideas about how to optimize the RPL code or other thoughts about the video. Thank you all for watching.